Today we will see the second year BSc physics experiment. Name of the experiment is temperature dependence of radiation. Now the apparatus is as shown. This is the chart of the experiment. Temperature dependence of radiation. Aim of the experiment is to study the temperature dependence of total radiation. Now the apparatus consists of 6-volt battery or battery eliminator, which is kept over here. This is battery eliminator. Then the apparatus consists of ammeter 1 ampere range. So this is ammeter of 1 ampere range. Then a rheostat, which is over here. This is rheostat. And a tungsten bulb. This is filament, tungsten bulb, filament, and a voltmeter. So this is voltmeter. Now the circuit is connected as shown in this figure. This is circuit diagram, which consists of 6-volt battery. RB stands for RH stands for a rheostat. A is ammeter, F is filament, and V is voltmeter. The connection is very simple, and this is how it is connected. The table shows, on this table the apparatus are there, and this is how the circuit looks like. Now what you have to do is, you have to find out the temperature radiation of this filament, how it is dependent on temperature radiation. For that purpose, what is the procedure is, you have to connect the circuit first, and then what you will going to do is, observation table is here, and this is the formula. What you have to find out is the resistance of a filament of bulb at Draper point. So what is Draper point is, voltage at Draper point and current at Draper point we will going to measure. Voltage at Draper point is Vd and current at Draper point is Id. So this is just glow condition. So when the bulb will just glow, will record the value of Vd and Id. So I will just show you. I am with the help of this rheostat, I am increasing the voltage, and just by increasing the voltage you will see, now this is how the bulb is glow. Now what you have to find out is just glow condition. So I will just reduce the voltage little bit, and now this is how the filament is glowed over here. So this is a just glow or Draper point, for which we'll get the voltmeter reading as 0.9 volt, and this is 0.22. Current in amperes is 0.22 amperes, and the voltage is 0.9 volt. So the Draper point will be 0.9 volt divided by 0.22. So you will get that particular Draper point's voltage. Then what you have to do is, find out the resistance at 0 degree centigrade, which is shown over here, the formula. You will get Rd because of Vd and Id, which we have just measured. Then what you have to find out is resistance at 0 degree, and so it will be R0 is equal to Rd upon 1 plus alpha Td. So alpha is given over here 5.21 into 10 raised to minus 3, that is the coefficient, and the temperature at the Draper point of the filament, that will be find out like this, which is 800 degree Kelvin, and Rd will going to put up just by doing the division of 0.1 divided by 0.22. So this is how you will get value of R0, that is resistance of the filament at 0 degree centigrade. And then next is, you have to find out the resistance at temperature T. For that purpose, what you will do, you will draw a table over here, in which you will change the voltages and respective temperature, respective current you will going to note down. So in steps of 0.2, 0.4 we will going to change the voltage, and respective current will going to measure. So how this is to be done, that I will show. Initially I will reduce the voltage. Now that is the lowest value. So instead of it is 0.2 now. So 0.2, the current shown over here is 0.6 0.06 or it is 1 येणार, म्हणजे त्याचं कॅलिब्रेशन करावं लागेल अर्थातच. देन यू विल इन्क्रीज द voltage in steps of 0.1. now this is value of voltage at 0.5. respective current is increasing, that you will going to measure. Light is not glown yet, the bulb is not, filament is not on. Once you go on increasing, this is how in steps of 0.2, 0.3, 1, this filament will start glowing. Simultaneously you will going to record the respective current. Then you will increase the voltage by moving this rheostat, and now the bulb also glows and the voltmeter also shows deflection, and this will be the maximum value when the bulb is fully glowed, and the value over here is 2.5 volts, and for that the respective current is 0.3 something, 0.38 or 39. You have to calibrate it, so it is below 0.4. so this is how you will take the readings in steps of 0.2, 0.3, 0.4 and so on, and you will note down the respective current over here in this column, and with the help of these values then further, now what you will do, you will find capital T with respect to this temperature. For that purpose you have to find out RT. So RT will be VT upon IT. You will get respective values of RT over here. After finding out RT, with the help of this formula RT is equal to VT upon IT, you will get RT, and this putting this RT in this particular formula T, that is RT minus R0 upon R0 alpha. R0 already you have with this formula. So this R0 value and this RT value respectively we will put over here, and with the help of this alpha 5.2 into 10 raised to minus 3 per degree, you will find out value of or temperature of the filament at that particular resistance. So this is how you will get values of T over here. Then we will find out absolute temperature respective value, log of that, then power of the temperature, power of that filament, that will be Vt multiplied by It, and log of power. So this is how the table will be, and after doing all these calculations you have to draw the graph, and that graph is RT on y-axis and temperature in Kelvin on x-axis, and that is a curve, and with the help of that graph now you will find out the log graph also, log of T on y-axis and log of P on x-axis. So this logarithmic and this one, both the graphs you have to draw, and after drawing these then you have to write down the result. I will post the chart PDF afterwards. So this is how you have to perform this experiment.